Sorry about that. I ran out of storage. I went ahead and finished it, but I will try to explain what I did. The two genes, this is the color gene, right? You're either a goody or you're solid, right? If you're little a, you are solid. Anything else with a big A, you're going to have an agouti color. The second set of genes just has to do with making pigment or not making pigment. If you have two negatives, you can't make pigment. This is a dominant gene though. The pigment gene is dominant, so if you have 1 plus, you can make the pigment for the other two genes or the other two alleles, all right? So if you end up in any case having two negatives, like this one, this one, 1, 2, 3, 4, those end up being white. Those mice are white because they can't make any pigment at all. So it doesn't matter what this other gene is doing. And since this other gene is working on the color of the difference in the color of the coat, that one doesn't make any difference. If you can't make any pigment, you can't make any color at all anyway. All right? And so I set this up as a dihybrid cross. I wrote down all the possible sex cells. This big A plus, big A minus, little a plus, and little a minus. Okay, so both parents are the same. They're going to make an equal number of each one of those sex cells. 25% of their sex cells are going to be that, so on and so forth. All right. So I filled out this chart based on those two genes, although they're both essentially coding for the same trait, which is the coat color of that mouse, right? This animal here is agouti because it has the big A, and it's got the plus, which means it can make pigment. All right, big A, yes, big A, yes, big A, yes, big A, yes. So I'm going to mark these. Yes, agouti, 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 and agouti. All of those animals have the big A for agouti skin, and they can make pigment too because they have a plus, right? They can make pigment, and so that's an agouti mouse. So I counted those up, and those are 9, right? 1, 2, 3, 4, 5, 6, 7, 8. Oh, I missed one. 9. There's 9 of those. And then any animal that is little a is a solid animal, but it also has to have the plus or it can't make any pigment at all. All right? So those solid ones that have the plus are this one, that's solid, it can make pigment, and this one. And so all 3 of those are solids. All right? Now, there's 3 other ones that have double negative. They can't make pigment at all. No pigment. So regardless of what these 2 genes are, they can't make pigment because they have 2 of those, and so there's no pigment at all. So it doesn't matter what these are still going to make it white. Okay? So all 3 of these, all 4 of these are going to be white. White, 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 white. So there's 4 of those. All right? So the unexpected ratio, the non-Mendelian ratio, at least in appearances, is 9 to 3 to 4. 9 agoutis, 3 solid colored black ones, and 4 albino white mice. So this is not really an expected ratio, but because behind the scenes we know that this other trait is playing a part in making pigment, it actually works out to be sort of a new modern Mendelian ratio, actually. Yeah. All right, so let me know if all of this makes sense or which ones you get hung up on. All right, thank you.